Welcome back. I said that we would continue synthetic division and do something else with it. Yes, we're going to find function values with synthetic division. Well, what does that mean? Let's look back at a problem we worked earlier and let me show you something. If I said that my f of x equaled 6x to the 5th minus 8x cubed minus 5x squared minus 3x plus 1, and I decided to find f of 2, I could do it. That'd be 6 times 2 to the 5th minus 8 times 2 to the 3rd minus 5 times 2 squared minus 3 times 2 plus 1. So f of 2 would be 2 to the 5th is 32 times 6 minus 8 times 2 cubed is 8 minus 5 times 2 squared is 4 minus 3 times 2, which would be minus 6 plus 1. And when I totaled all of that up, I would get, would you believe, 103. Guess what we got for the remainder right here? 103. So the f of 2 actually equals that remainder of 103. That's interesting. That's what we're going to use here to work a problem, finding the f of 4 for this particular function. F of x equals x cubed minus 7x squared plus 9x minus 4. So I need no zero placeholders because I have third power, second power, first power, and then no x's, x to the 0 power. So I'll put down my coefficients, 1, negative 7, 9, negative 5, and I'm going to run through a 4. You said, but you usually change the sign. That's when I have an x minus 4. Then I find the x value if I set that equal to 0. I'm given the x value, so I don't need to change it here. So bring down the 1. 4 times 1 is 4. Negative 7 plus 4 is negative 3. Multiply 4 times negative 3, get negative 12. Add, and I have negative 3. 4 times negative 3 is negative 12. My remainder is negative 17. So the f of 4 equals negative 17. So if for some reason I want to know that, and I don't want to go to a calculator to help me, this is a really quick way to get a function value. Well, I wonder, can I do that with fractions? Sure. Let's look at this. Do we need a placeholder? Fourth power, third power, second power, first power, 0 power. No, we don't need a placeholder. So 6, 10, 7, 1, and 1. And we're going to run through negative 2/3. I know you're dreading it. It's not as bad as you think. Bring down the 6. Now 6 times negative 2/3 is negative 4. You don't believe me? Let's come off on scratch. Negative 2/3 times 6. 3 goes into 3 once, into 6 twice. Negative 2 times 2 is negative 4. So 10 minus 4 is 6. Well, I bet you know what negative 2/3 times 6 is this time. Negative 4. So 7 minus 4 is 3. Let's make a nicer 3. Negative 2/3 times 3 gives me negative 2. Adding negative 2 and 1, I get negative 1. I've been so lucky. No fractions down here so far. My luck's fixing to change. Negative 1 times negative 2/3 is positive 2/3. I need to add 1 plus 2/3. I can certainly punch it in on the calculator and get a decimal. Then go to my math screen and tell it to change it to a fraction for me. Or I can say that I need a common denominator of 3. And of course 1 is 3 over 3. Multiply 1 by 3 in the denominator to get a 3 in the denominator here. Do the same thing in the numerator, so I've just multiplied by 1, and I have 3 over 3 plus 2 over 3. So I put down the common denominator of 3, add numerators, 3 plus 2 is 5. So remember, I do not add denominators. So my remainder is 5/3. That is the F of negative 2/3. It's 5/3. I wonder if that always works. Let's think about what we've written out before. We say that our f of x equals our quotient polynomial times our divisor polynomial plus our remainder. And if we're dealing only with linear functions in the denominator, then our remainder has to be a constant. All right. Are you sure about that, Ms. Heaton? Sure. Let's look at this. X squared plus 3x plus 5. And we're going to do long division to convince you. We're going to divide by x plus 2. So x times x squared gives me x squared plus 2x. Draw a line, change signs and add, and I have x plus 5 plus 1. I can still go because I have an x down here. So x times x times what gives me x? That would be a 1. 1 times x plus 2 is x plus 2. Draw a line, change signs, and add, and I have a remainder of 3, which is a constant. So when I'm dividing by a linear factor or divisor, I know it won't divide anymore only when I get to a constant, because it's still dividing when I have just an x here. So I know the remainder's a constant when my divisor is linear. Okay? Let's say the divisor is something like x minus k. So if I'm now finding the f of minus k, then I'll have a k here. And I've got some quotient right here with a k in it. So does it really matter what that is? Because if I'm finding the f of k, I'm going to plug k in everywhere here and here. And when I plug k in, that second factor, the divisor, I get 0. So the f of k is the remainder when x minus k is the divisor. So that's how we're finding the function and function value. And yes, it works every time. We can see it right here. So hopefully I have convinced you that f of k indeed equals r by the one we just plugged in k for. And that concludes finding function values. Next time we'll look at finding zeros and roots.